Hi everyone. In the last session we have seen a few problems. In today's session we will see another problem on DC shunt motor. The problem statement is a DC shunt motor with an armature circuit resistance of 0.3 ohm operates an hoist whose efficiency is 70%. Calculate the size of the DC motor for raising a load of 800 kgs at a speed of 3 meters per second. In case the supply voltage falls from the initial value of 230 volts to 190 volts, calculate the hoist speed. In the previous problem, we have the speed has reduced from some 6 meters per second to 4 meters per second, and correspondingly, what is the external resistance we need to add to the drive or to the armature? That's what we were discussed in the previous session. In today's session, when the voltage falls from 230 volts to 190 volts, so calculate the speed. Here we need to find out the speed. So from the given data, again we can find out, as they were given the mass of the load, we can find out the force due to the gravitational pull, that is M into G. M they were given 800 into G 9.81. So we will get the force in Newton, that is 7848 newtons. So now when we know the force and the corresponding speed, the rising speed is 3 meters per second to lift this load. So once if we know the force and velocity, we can find out the power. The power required to lifting the load is nothing but F into V. So 7848 into 3 meters per second. That will give the power required to lift the load. So what else they were given in the statement? They were given the efficiency also. From the given efficiency, the efficiency is nothing but mechanical power developed by the electrical power input. So already we calculated the mechanical power developed, that is nothing but F into V is nothing but power. So substitute that efficiency 0.7 in this equation and mechanical power developed, so that you can get the electrical power input. It is nothing but electrical power input is nothing but power rating of the DC motor, which is equal to F into V by efficiency. So by substituting these values, we can get the power rating or power developed at the DC motor, which is equal to 33,634 watts. Now we got the power developed at the DC motor or power rating of the DC motor. So how can we get the power rating of the DC motor in terms of electrical quantities? So to calculate the electrical quantities, by using these electrical quantities, the supply voltage they were given as 230 volts. From the given data, the back EMF, to find out this back EMF equation is nothing but V minus IA into RA. In this, IA is unknown. IA they were not given in the problem statement. So keep as it is and substitute the remaining values, that is 230 minus IA into RA is 0.3. Now the power developed by the DC motor is nothing but back EMF into current, corresponding armature current. So EB into IA, here IA is unknown, still unknown, but we know the power developed by the DC motor by using that efficiency equation. We got 33,634. Now we can equate this EB into IA is equal to 33,634. In this EB into IA, EB is equal to 230 minus IA into 0.3 of IA is equal to 33,634. By calculating this or by solving this equation, we can get the IA is equal to 196.7 amperes. Now we got IA value. So in the problem statement, they were asked the value of the voltage is changing from 230 to 190 volts. So with respect to the 190 volts, now we will calculate the back EMF by assuming the armature current is constant. As in the problem statement, they were not given anything about the armature current. We assume that armature current is constant. So now we will calculate the new back EMF with respect to the 190 volts. So 190 volts EB2 is equal 190 minus IA 196.7 into armature resistance is already they were given in the statement, that is 0.3. By substituting these values, we will get the EB2 value. EB2 is equal 130.99 volts. Now we got EB2, we know the IA value. EB2 into IA will give the power developed at the DC motor, and what we need to find out? We need to find out the corresponding hoist speed. To calculate the hoist speed, we need to find out the mechanical power developed with the same efficiency. By using the again same efficiency formula, assuming that Ia is same, so EB into Ia is equal to that EB 196.70 into Ia is equal 130.99 is equal, EB into Ia is equal to mg, right? F into V, already m we know, 800 into 9.81 into corresponding new velocity, F into V by corresponding efficiency. So by solving this equation, here V is only the unknown value, we will get it as the hoist speed V is equal to 2.298 meters per second. So the hoist speed is reducing to 2.298 meters per second when we are reducing the voltage from 230 volts to 190 volts. That's what this problem. Thank you all.